That's... Are we... I bounced the stream. Hello. That's... Are you with me now? I've bounced the stream. I bounced the stream. Hello. Okay. I've been talking to myself for over an hour, so let's not ruminate on that being embarrassing. With me now. I've bounced the stream. Hello. Well, that's very embarrassing. I just thought, you know, it's a coding stream. We weren't going to have many people around, but no, actually, people are around. The stream just had an issue. Well, I've bounced the stream now. We've made such great progress. We'll keep making progress. So deck objects, we want all the deck objects for a side, and we want a depth filter, which is a function from the depth to a boolean. That's pretty much always the operation we want to do. Except some of you just want the depth. Nah, don't worry about that. We'll just leave it as it is. Okay. So we get all the corpse deck, we get all the runner deck, we shuffle them on top of their respective decks. All right. That's shuffling implemented again. Here we're just using an arbitrary order, but we can actually do a little thing here. So if I do a panic at the end so that we actually see the output, and if I do for card in nr deck object side corp, nr.objects.get card, let card is this. Does this implement debug in a helpful way? Yes, it does. All right. So now if I run this test, we should see a load of shuffled cards. Nope. What don't we like? Right, that's my explicit panic. Oh, hey, look, it's a load of not really that shuffled cards. Are they in just reverse order? No, they're just insertion order. Cool. That's fine. It's because we don't actually shuffle them here, because I'm not doing any randomness. Let's just get the names, actually. So if I do unwrap dot kind dot as card. I haven't implemented that yet. Okay, let's go implement that. I've done is card. Okay, pubfn as card. Option card object. Match self. Okay, as card dot okay. Unwrap the card, get the card name. Okay, now we should just be printing all of the card names. Okay, cool. And then let's implement a real shuffle. There is a randomizer that doesn't use an external crate. It's just kind of hacky because you have to use the internal hash map thing, which doesn't feel great. So let's just add rand and remember to remove rand. Cargo, add rand, probably with some features turned on. Nah, we're fine. Okay. So here we'll collect them into a random list, and then the R&D crate lets us shuffle them. Hold on, rand rust. Shuffle? What's shuffle implemented on? It's implemented on slice random. Objects that won't support slices. That's annoying. There's also iterator random, right? No, that's used for random sampling methods. Okay. Yep. Okay. So let's not collect them from an object set. Let's collect them to a vector of object IDs. That way we can slice them. And then we can call shuffle on that. Through use rand sec iter slice random. Right? Shuffle modifies its receiver in place. Okay, we will say let cards to shuffle is this. Cards to shuffle dot shuffle. Cards to shuffle as an iterator. Ammute rand thread RNG. That's a thing, right? Feels like a thing. Run that test. That still doesn't look like a random order of corp cards to me, which is not a good sign. Alright, operation. Why is this not random? Is our shuffled list of IDs random? Let's just have a look at those. So if we do this, do these look shuffled? These look pretty shuffled to me. Yeah, there's no like sensible order to those numbers. If I remove the shuffle, is there a sensible order to those numbers though? Good question. Let's wait. That's before the shuffle. Okay, cool. Wait, no, that's okay. If I print it before I do the shuffle of those numbers, they should now be in a sensible order here. Yeah, so now here they're in order. So we're definitely shuffling those. So the issue isn't with generating this. The issue is with consuming it. No, the simulator isn't dealing with any randomness. Rand here is just for my test case here, so I can check the shuffler works. Like, if you give it cards to shuffle, it will actually shuffle them. You know what it is? We get the objects out in order here, and we're not sorting them by their depth. So that's why these don't look shuffled. We need to sort them by their depth. So what we actually want to do is we want to get all the corp, all the deck objects for the corp, and then we want to collect them into... Well, hold on. We want to do map all of them into their appropriate object. And then we want to collect that into a vector. Let mute corp deck is this. And then corp deck dot sort by key. Obj dot location as depth, something like that, I think is the code here. Yeah, okay, as depth in mute side. Right, okay. Yeah. We want to just do object dot location. We'll write it manually here. Match object location to depth. If it's not in the corp deck, just give it depth 0, and let the shuffler, let Rust stable sort them. Okay, for card in corp deck, print line that. Okay, now when we run this, we should see a shuffled deck. Oh, hey, look, it's a shuffled deck. Okay. Uh, hello card. There we go. Cool. All right. Shuffling works. And we have a much, 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 much better logic behind how objects work and all of that nonsense. Okay. After shuffling their deck, each player draws 5 cards from the top of their deck to form their starting hand. Okie dokie. So we are going to want to implement draw starting hand for our game state. Where did I put my other game starting credits here? Yeah. So because drawing your starting hand is like not subject to a lot of mechanisms, it's kind of a raw operation. We'll implement the draw command, the raw draw command here. I want to prefix all of these that are not doing anything fancy with raw, but for now I'll just call it, I'll say draw. I'll call it special draw. That's what I called it last time. Side is side. Well, you draw simultaneously here, but yeah, side is side, and the amount you draw is count. Okay. So now we can implement special draw. And special draw just means it doesn't use all of the normal machinery, which means there's no replacement effects, no interrupts. We're just ripping a card off the top because that's how your mulligan, your pre-mulligan and your post-mulligan draw work. Okay, so special draw. And we'll call special draw from draw after all of the other machinery as well. This just needs to move stuff, and we've implemented moving stuff. So self dot yeah, we just want to get all the IDs of all of the top 5 cards of the deck and move them out. That's easy. So we want to do objects dot values dot filter map object dot location if side is side corp, if side is side runner, then grab the depth. Okay, so that filters us down to just the cards we want, and then we want to filter those for where the depth is. Do you need to allow exceptions from drawing for a bigger starting hand, like with Andromeda? No, because we are NSG only. So until No Signal Games prints a card that can draw more than 5 opening hand cards, we won't. And when we do, then on the comprehensive rules, there is a dedicated step for resolve weirdness. And so in that resolve weirdness step, we would just increase the draw count and create a variable for it. But for now, it can just be hard-coded at 5 until such a time as NSG prints a card that can draw a different number. 0 is top of the deck, so yep. If depth is less than counter, then we care about it. That gives us everything we need. I guess actually here we want to filter. Here we want to do we need to retain the object. Some object depth. Object depth. That should all be correct, right? What are you not? One of these is not enough. One of these is too many. Okay. So we're going to filter it for the depth. And then after we filter it down, now we can discard the depth. So I actually probably just say, you know what I can do? This is kind of awful, but I think here I just do object.ifSum. Yeah, this is awful. But this is the really easy way to do this. Then Wait, yeah. It's this giant match thing. But here we care if the depth is less than 5. Here we care if the depth is less than 5. And here we're always false. Right? Yep. Then some object. Okay. That gets us our object list. We can say so let toDraw is equal to collect into an object set. Right. Object ID cannot be built from. Right. Then some object ID. Okay, that gives our list to draw, and then all we do is we say for object into draw self.move object to draw to location HQ and location grip. Okay, that should draw cards. We can test that by after we shuffle the top of the deck. We can just do nr.special draw side corp 5 side corp side runner 5. So now they should both draw 5 cards. How are we going to find these? We're going to say we want hand objects for the corp. And I'll go implement that. Deck objects is here. Let's go add hand objects for HQ and R&D. Nope, HQ and stack. Nope, and grep even. Okay. It's nice that Rust gives me error messages when I type the wrong thing. Yeah, there's not a pretty way to write that code, but it'll work. Okay, so now we should just list everything in... We don't sort them by depth anymore. So we can just say this is corp hand, and corp hand is unordered, so we can just print everything in the corp hand. Right? This is fine. All right, let's draw a card of 5 draw 5 cards. Off-world office, hedge fund, palisade, mayfly. Those look like corp cards to me. What about the runner? What's the runner got in their hand? Ooh. What indeed does the runner have in their hand? Why? Okay, question for the class. Why does the runner not have anything in their hand? Stack. If the side is the runner, move to the grip. Mayfly isn't a corp card. You're right. Okay, hold on. Let's go look at that again. Smartware distributor? What are you doing in the corporation's hand? You don't belong here. Good spot, Game with Droids. Okay. We should only be grabbing from R&D if our... Okay, well, first of all, this should say counter, not size, but, like, you know. Am I putting things in the wrong decks? Hold on. These are corp cards. These are runner cards. That looks right, right? This is all the cards that are currently in the simulator, and none of them are implemented. Yep. Okay. And then when I do my registration here, and we do add card to deck, we look at the stack and R&D for the runner and the corp based on the owner of the card. And then we insert it so that corp cards go into R&D and runner cards go into the stack. And they're controlled by their owner. Okay, yes. I'm confident that they're going into the deck where they should be. We can double check that though by looking at let's inspect deck objects for the corp and check that it's just corp cards in there. It's probably a quick and easy way to check that. That is not just corp objects. Okay. If I remove the shuffling, is it then just corp objects? Is shuffling screwing it up? Shuffling is screwing it up. Okay, so this thing here is putting everything on the corp deck. I found the problem. We're shuffling all the runner cards onto R&D. All right, good spot, bug fixed. Let's go back to looking at the runner hand to check that that works. Runner hand. And now the runner hand has stuff in it. Sure Gambles and Mayflies. Give me a different set. What we got? We've got more Sure Gambles and Mayflies. Well, you know, that is most of the cards in the deck, so that kind of checks out. Let me just hammer that a few more times. Okay, a different number of Sure Gambles and Mayflies. This one has some Smartwares in it. Okay. All right, we're no longer shuffling all of the runner cards into the corp deck, and we have shuffling implemented. All right. Next up. Mulligans. Each player draws 5 cards. Okay, we need a mulligan function. Mulligan is really simple. We just add PubFN mulligan, self, side, side. We're not implementing any timing structures right now, as you may have noticed. So mulligan is really simple. It's just self.shuffle on top of deck. And the things we are shuffling is self.deck objects for the side. Hold on. STD iter once. Deck objects for the side. I guess, no. Empty. Chain. Chain self.hand objects for the side. Yeah, okay, so we do let deck and hand objects is this object set. Okay. Really, we should be looking for an into iterator. Item is object here, and then I don't need to call that here. Okay. Right. We shuffle all of this onto the top of the deck, and we draw self.special draw. I guess we should probably say what your draw count is, just in case that becomes relevant again in the future. Okay. That is mulliganing implemented. God, it's easier when you've got everything implemented in a way that makes sense, because it's your 5th time rewriting this code. Not that it's my 5th time rewriting this code. It's my 5th time rewriting this code. Okay. Mulliganing. Done. With that, we are through all of the start of the game. Either player mulligans. We're not worrying about timing structures. Timing structures aren't real. So to lay out the innovation, to lay out the goal, here we're implementing all of the stuff what does things, and then timing schedules are essentially going to be a wrapper around it. I kind of know what I'm doing with this at this point, I think. So yeah, timing structures are fake. We're focusing on the raw functionality, and 80% of that raw functionality is moving counters around. So done. Let's implement some stuff. So a load of timing structure stuff happens, and we probably want to do a thing. For example, the first thing that happens in the game is the corp draws them, makes their mandatory draw. Mandatory draw. So the mandatory draw is a thing that the game can do where it produces a mandatory draw effect. Really, apply instruction effect. Effect, instruction, effect. These exist somewhere about them. They do. I probably just don't include them in here yet because I'm not using them yet. Pub mod effect. Okay. Get rid of each reset. We don't use it. Okay. Lib, you okay? Yes. Okay, so all right. Every effect needs to be applicable. Honestly, this should be written in instruction effect. What's our first instruction effect? So an instruction effect is anything that is an instruction. It is an effect produced from an instruction. These are different from declaration effects, which are produced by declarations. An important thing to understand about instructions in Netrunner. Instructions. Every step in a timing structure is an instruction. This means that all of the things the game does in its timing structures are also instructions. So we're going to just add in, we're going to add in timing instruction. But I'm just going to do it flat here. We're going to do timing effect mandatory draw. So timing effect mandatory draw is something that can happen. It produces a regular draw effect, right? And I think that's all it should do. So I think if we go and implement these, then all this one should do is it should apply instruction effect draw. Okay, and then instruction effect draw is where stuff actually lives. But we'll do this over in the effect implementation. So in here, we're going to do implement instruction effect, pubfn apply to game state. Okay, so effects happening. Now, also whenever a counter moves, we're going to need to log that the move occurred in the game history. That's a whole thing that needs to exist, but we're not going to worry about that right now. We'll worry about that when we implement cards that care. Okay, so we're going to apply our instruction effects like this. Okay, so first of all, the timing effect mandatory draw, which I'm just going to call TE or TI. So TI mandatory draw. That's timing instruction, not short for timing, and this you would write like this in Rust. So timing instruction mandatory draw. All this does is calls draw instead. This defers to draw. If anything ever has to care about the fact you've done your mandatory draw in implementation, we'll add it here. But for now, mandatory draw is just draw. And draw, for now, again, draw is just special draw. Now, we do care about who made the draw. So draw does have a side associated with it. And mandatory draw is actually going to create draw for side corp. Okay, and so draw for side. Now, draw also should have a count associated with it. So here you're going to draw 1. Draw for side and count. Okay. Because in Netrunner, you draw multiple cards at once. And for now, we're going to special draw. This shouldn't special draw. Drawn cards go into the set aside zone. There's a whole load of machinery around what that means. But for now, I think it's fine for them to just go into the set aside zone. It's fine to ignore that. And I'm going to just say here, in reality, drawing is more complex. Cards are set aside, then a checkpoint happens. Then they go to R&D. Go to the hand zone. See steps of drawing N cards 8.4.5 for more. Okay. But we're not going to do this until we have a card that cares about it, because we're building an implementation that's going to see production. Okay, drawing done. We can draw cards. We can issue a mandatory draw. Let's test that. We can over here in our thing, and and in reality, the timing scheduler would do this, but like we don't care about the timing scheduler right now. We're gonna say nr dot. This should still have an apply effect. This should be pub fn apply effect, AMI itself, effect, instruction effect, apply, instruction effect, effect dot apply self. Okay. So we're gonna do nr dot apply instruction effect, timing instruction mandatory draw. Okay, now after a mandatory draw, we should have 6 cards in our hand instead of 5. Oh, hey, would you look at that? 6 cards. Nice. All right, but steps of resolving. So here's the thing. They're all written separately in a way that's really annoying. But if you look at anything, how it actually works is whenever an instruction happens, a checkpoint happens immediately after, and an interrupt window applies immediately before that can modify imminent effects. Imminent effects are a thing we're going to need to care about soon because of a card called verbal plasticity. But right now, those don't exist. And as long as I have this abstraction here of apply instruction effect, I can just like to do interrupt effect, to do checkpoint. The spin up and the tear down, sorted. Don't care. Right. Okay, that's that process done. Where are we at? I think where we're at is, while I may have only been live in reality for half an hour, I have been going for an hour and a half because of a small kerfuffle at the start of the stream, involving me having issues and having to bounce the stream and not realizing. So I am going to take a short break. I'll be back very shortly. Sorry there's no music for you this time. I couldn't be bothered to faff around with breaking the music into channels, so I can hear music, but you can't. But I will be right back. I'm just gonna grab myself a snack and get myself ready for the next chunk of this, where we're gonna start looking at all of the stuff we need to support the very limited pool of cards that I've said we're gonna have in the first part of this. This is like minimum viable Netrunner things. We have one of every type of card, basically. And we're going to try and implement a full game just on those. And none of the really complicated cards are here. Mayfly has a suspended conditional effect. That's the most complicated thing. We'll start implementing playing cards and basic actions and all of that stuff. So that aside, for now, I will be back in a little bit. All right, I'm back. Let's double check that the stream is receiving me, because clearly we had issues with that earlier. All right, I'm back. Yep, cool. So, what are we on to? We are on to what happens after a mandatory draw. A paid ability window. Do I care about that right now? Not really. I'll just add it in later. Okay. Paid ability window is a problem for a little bit because they're a timing problem. You have the opportunity to activate abilities, but you're not going to have any abilities you can sensibly activate. That means we're through to the take an action instruction, which is timing instruction that tells you to choose an action and perform it. The actions available to you are the basic actions and any actions that are active on any cards that are installed, but active actions on cards that are installed aren't real yet, so it's just the basic actions. So, we need to add in pubfn take action and mute self action. So what is an action? We'll just call it an action for now. We'll go make a new action.rs. Let's add it in here. You've got pub enum action, basic action, and then you've got card action, which object action. An object action requires you to have an object ID and the index of that action, which we'll talk about later. But for now, this isn't real. That's coming later. But basic action is real, and basic action, there's a whole ton of them. There is basic action draw. There is basic action gain. There is, which I'm going to call these BA. We've got bad draw, and again that's short for basic action. It's just draw a card, gain a card, play a card. Playing a card requires you to specify the card you're going to play from your hand, or grip. You've got BA install. Okay. Play install. What do we have after play and install? We have my basic action. Basic trash ability is where it'll be written with, right? Got them. Right, let's quickly pivot over to the web browser. Here. Gain, draw, install, play, and then it's the specific ones. So what have we got? We got basic action run, and run requires you to specify a server, and we've not implemented servers yet. We'll get there. So let's not bother implementing BA run yet. But it's going to need you to have like a server to run. Advance we can do. BA advance. Because BA advance just needs you to have an object you want to advance. Trash we can do. Okay. And remove tag. BA remove tag. Right, those are all like pretty salient, sensible things we could be doing with our time. That's all the basic actions. Everyone agrees these are all the basic actions. I'm pretty sure these are all the basic actions. Purge. BA purge. Hey, and purge, always kigs. Don't need to worry about nkigs on purge. Yep, we're implementing nkigs. Okay. To that end, actually, we should update our draw such that when the draw effect would happen, if game state dot deck objects for side is 0, then there's nothing to draw and you lose the game. To do if you're corp. If side is side corp and that implement losing the game. Cool. Okay. Okay. We've left a note for future me. Okay, and now here we can implement taking an action, and this is going to be really easy. It's going to be action dot take. Okay, and then in here we're going to say implement action take. Take self game state mute game state. Okay, so taking an action, nice and straightforward. Let's take some actions. Draw's really easy. Draw produces the action. So steps of taking an action, basically. Steps of taking an action doesn't exist. You take an action. How's it worded in here? Corp takes an action. Okay, cool. Steps of resolving a paid ability. Paid ability. Steps of using a paid ability. Here we go. Because this is what you're doing when you take one of these actions. These are all paid abilities. They're just specially hard-coded paid abilities. Oh, you know what? We need to give clicks. Let's give clicks. That's an effect we'll need. So our game state, we actually have runner clicks and corp clicks. Those are numbers that exist. And they actually can't go negative, unlike a lot of numbers in this game, right? You can have a negative number of clicks. You stay at 0. Runner clicks 0, corp clicks 0. Okay, nice and easy. So GS, let's go back to our effect real quick, and we're going to add TI gain clicks. It's a timing instruction effect that we'll need to take, and this tells us that we need to implement it. Gain clicks. And gaining clicks is pretty straightforward. It's just we need to know which side is gaining the clicks. And then in future, we might need to look to see if there's any static effects modifying the number of clicks you have. Sorry, any declaration effects modifying the number of effects you have. But for now, you gain the appropriate number of clicks. Match side. If you're corp, gs.corp clicks equals 3, and gs.runner clicks is 4. Okay, we have implemented the ability to get clicks. Cool. So now we have clicks, we can spend them. Announce the intent to trigger the paid ability. This is what you do when you call this function. Okay. So we'll say that this here is announce the intent to trigger a paid ability. We'll call it announce to make it clear that that's what it does. Okay, so you announce your paid ability. You announce an action is a kind of paid ability. All the machinery here will end up in both of these. In fact, technically, action is a subset of paid ability. It's what you have to do here. To the point where paid abilities. Let's actually do this in here. We'll do pub mod paid ability. Paid ability, pub enum paid ability. Paid ability actions are a kind of paid ability with a special timing window. Implement paid ability, pub fn announce. Okay, let's go grab this, eat it here. Happens on paid ability. And then straightforwardly in here, when you take an action, you are doing a paid ability, action, and you're announcing that. Okay. So you announce the action as paid ability. Cool. Steps. Announce. Done by calling this. Step 1, announce. Done by calling this. Step 2, pay the trigger cost. Pay the cost. Okay. Every paid ability has to have a cost. Actions are no different. Let's implement action pubfn cost. And we'll need to implement costs. Costs lib pubmod costs. Pub struct cost terms. And this is where we'd also need to look at declaration effects for reducing costs, would be during the announce step, but for now we're not worrying about that. Okay. And what's in a cost terms? We have, we'll just call this a cost. And then we'll say it has cost terms in it. Cost terms, and one of those can be click, because that's all we're dealing with for now. Okay. Technically, I don't know if they're ordered. Yes, they're ordered, because some stuff will have multiple. Yeah, okay. Okay, we have to return a cost. Basic action draw has a cost. We want to make these really, really quick to make. Should be cut on. Okay. Will this always be clonable? Yes, because we will store any instructions as special resolution instructions, which will have their own thing. We're fine. Okay. So announce, done by calling this. Step 2, pay the cost. We're going to pay the cost. So first we need to get the cost. So we're going to do pubfn cost, self-returning cost. Cost can depend on the game state, but it can only depend on reading the game state. And for the actions, it's never going to matter, because we're just going to forward to action.cost, because none of the costs of basic abilities, click here, none of these costs depend on anything. Like there's no dependencies on what's the word I'm looking for? Anything in the game state for these. So for now, we don't actually need the game state, but we will need it later. Okay. Self.cost. So we get our cost, and then we need to pay our cost. Now, if you can't pay the cost, you couldn't take the action. It would be a no change in game state. So we actually do need to say here, we need a pubfn has the potential to change the game state. Returns true if taking an action has the potential to change the game state. because NKIGs isn't actually a thing. We all call it NKIGs in the technical like rules community, the technical rules community consisting of 3 people. We call it NKIGs, but it's actually called. It has the potential to change the game state. And an action, we can just let the action verify that it has the potential to change the game state. Action dot hey action, guess what? You're also going to have this as one of your things. And for here, what we'll do is we'll just do the effect generation as a dry run effect generation is how you do this. But yeah, we'll talk a bit more about that in a sec. Here, true. These have the potential to game state. They don't actually, but like we're just going to assert that they do for my own mental health. Okay. For now. To do NKIGs. Okay. Returns true if using an ability has the potential to change the game state. Okay. Guess. Okay. Everyone loves a bit of hutapatakatus. Say it with me. Hutapatakatus. Okay. You're fine. Cost. You just import cost. Okay. So we have our cost. We know how much it costs. We then have to pay the cost. Which I guess is a thing that cost should have. Is cost should have pubfn can pay as a check that it makes by observing the game state to tell you if it's able to pay. Which for now we will just say we'll just look at your click count. So yeah. Now costs don't exist in a vacuum, they have a payee. So we also care about the payee, which is a side. So we're saying, does the payee have the ability to pay this cost? Okay. Yeah. Now, cost terms, it's important to remember cost terms are generated from the state, so they can include specific objects, and we're just asking, does the player control those objects? Yes. Okay. Clicks are nice and easy, though. Okay. Can you pay? Pretty straightforward. Self.terms. For term in self.terms. Side clicks is equal to match payee. gs.corp clicks. gs.runner clicks. Side clicks match term. Side clicks minus equals 1. This would be no. Let me spent clicks is 0. Okay. This checks if we can afford click costs. When we add in credit costs, we'll handle those. Okay, so you can pay. Once we've established you can pay, we need to actually pay. How is paying going to work? Well, some costs are going to require you to actually like choose things, like counters. But for click costs, it's nice and easy. Paying them is just paying them. I think what we'll do here is we'll say pubfm pay. And for now, it doesn't need to do anything else. It just needs to modify the game state. Payee. And we will just do match payee. gs.corpclicks.checked saturating sub. We'll just say for term in terms and self.terms.iter match term, which currently can only be clicks. And for clicks, what we do is we say match payee. And if it is the corp, then we do self dot we say do gs.corpclicks.saturating sub 1, gs.runnerclicks.saturating sub. Saturating sub isn't in place. Must use. Is there an in place version? No. gs.corpclicks is equal to gs.runnerclicks is equal to saturating sub 1. Okay. That pays the cost. So now in our paidability, cost.pay. Now, announcee side. We need to know who announced it. What is this music? I know you guys can't hear it, but I can, and I'm vetoing it. Okay. Step 2. Pay the cost. Next up, steps of using a paid ability. Okay, this is then instruction resolution. And instruction resolution is a very important system to get right. To the extent where we're going to make a new file called instruction, because instructions produce effects, and there's a lot of them. This basically happens whenever an instruction would resolve, or you resolve a group of instructions. You announce the targets for the instruction, then the instruction becomes imminent. Then replacement effects happen. Then the instruction resolves, the effects are applied, then a checkpoint occurs. That's the core loop. Now we're not worrying about interrupts and checkpoints yet. So for us right now, straightforward, it's just applying the effects. So for us right now, actor side, actor. Okay. We'll call this announce. We'll say this is use PA is what this needs to be renamed to, I think. Right. Okay. Actor and then self. Okay. So we pay the costs. And then after we pay the costs, we have to do instruction resolution. Now, instructions are just batches of effects. They're a bit more than that because they can involve decisions, but at their kind of very, very fundamental level, an instruction is a batch of effects. So I actually think maybe we don't need this instruction section. Maybe we just say instructions are batches of effects. Are there any instructions that aren't just a batch of effects? Just instructions that involve decisions, and those are never interactable. There's no printed card that says when the corporation would choose between different modes on a card, they must choose at random, right? And if Cephalopod ever signs off on that being added to the card game, I'm gonna reject that card's existence because that sounds like a dumb, not very Netrunner card. Yeah, so I think fundamentally, the comprehensive rules kind of lie here, and the only things that are actions are batches of instructions. So I actually think we just do here where we have apply, this applies a single one. In the library here, we had apply instruction effect. This should be apply instruction effects. Impl into iterator item is instruction effect. For effect in effects, apply them all. Okay, wonderful. Technically, I guess it's an iterator. It has to be a repeatable iterator, which is what into iterator is. Okay, we're fine. Okay. Yeah, so it's going to spit out instruction effects for us to run. And then in here, where we're doing our mandatory draw, we now need to make it an iterator of mandatory draw. Okay. Okay, we are back in effect here. Nope, in ability. Delete instruction for now. Step 3, resolve the instructions. So an ability can have multiple instructions. Do I acknowledge that reality? No, not really. Yeah, they have to. Okay. Because you can have an instruction, then a decision, then an instruction. So what we will do is we will... Yeah, so here's where we need to ask the ability what... the way we asked about its cost here we need to get its instruction batches. Its effect batches. Yeah. Which might require suspending for a decision. Hate that. That's all timing structure stuff. That's all controlled by the timing sequencer. So when you use a paid ability, all that really happens is that we add the next instruction to the resolving instruction set. And every ability can be broken down into a discrete count of instructions, so we just enumerate through them. So all we need to do is add into our game state, which is in lib, a new thing. And that new thing is pub imminent instruction effects, which is going to be a hash set of instruction effect. Okay. Nope. We'll make it a vec. They're not ordered, but we're making it a vec for code simplicity. Okay. So this is all of the stuff that is about to happen and that needs to be kind of signed off to happen by whatever's controlling the timing structure. Because the instruction to use is just kind of puts it into this. Now, after that, we need to come back and do the next instruction, though, because we need to know which instruction we're on. So we kind of need like an instruction counter that starts at 0. Yeah, let's actually do that. So we have an instruction counter at 0. Which tells you which instruction we are on in a sequence of instructions within an ability. Yes. Yeah, and if an ability is modal, then we just program different instructions as being part of that modal sequence. Okay, interesting. And then they have a jump back instruction counter. Okay, it's a virtual machine. Of course, it's a virtual machine. It's a card game. They're Turing complete, usually. Netrunner's Turing complete. We Turing completed Netrunner. Anyone know if we Turing completed Netrunner? Is Netrunner Turing complete? Netrunner is Turing complete. Why am I not surprised? Of course it is. If anyone wants to read that, I'll dump it in chat, but, you know, hey-ho. No surprise we're implementing something that's Turing complete with an instruction counter. Okay. So, when you use the ability, then that ability becomes the resolving ability, which might be nothing if there's nothing being resolved. This actually has layers to it. Yeah, so we actually just want to have like some resolving structure. Resolving. So this is where like you have a resolution stack. Because as much as they try to avoid it, there is a stack in Netrunner. Because you could be resolving the make a run instruction on a card as part of, and then you can do instructions inside of that. So this right here is our resolution stack, which I'm just going to call a vec of resolution step. Okay. We are definitely going to add pub mod resolution for housing each resolution step. Okay. And the resolution step we care about here is that we are resolving a use ability, use paid ability. And we have a ability, and we have a instruction counter. Okay. So when you use a paid ability, it's actually really simple. After you pay the cost, resolution stack is empty. After you pay the cost, all we're doing is gs.resolutionstack.push resolution step use paid ability. Paid ability we're using is self. These should always be trivial data because they're always object IDs or side or pointers to another instruction to resolve, which is one of the big changes here. Is I'm doing everything declaratively like this rather than having nonsense happen. So our ability is self. And we are at instruction 0. Wonderful. And then that can push the steps of its instructions on top of itself. Okay. And the timing structure is in charge of checking that if there's anything if there is a use paid ability, if there is anything in there to resolve. Okay. And the ability can declare when it runs out of instructions. Right. So that's everything you do here, right? So then you just hand off to the instruction process until the ability's over. So step 3. So we'll just say you pay the cost. Okay. And you won't be able to call this for an ability you can't use because whatever enforces timing structures and calls all of these Hutapitakas functions will do that check for you. Okay. That is using actions implemented. So let's go start using an action. Let's say that action in our test. So we are going to Corp's going to gain clicks. We're going to make our mandatory draw. And then we are going to click for credit. No, we'll draw. We know drawing works. So we will take the action for the corp to action BA draw, which I guess doesn't need to store its side anymore because we know who the actor is. Ahead of time. We know who the actor is from the thing anyway. Okay, so draw. This has got a cost of a single click. Let's fill these in. So click to draw, click to gain, click to play a card, click to install a card, This has an additional cost term, so we'll not implement it yet. This here is click, click, click. Okay. So those are all the costs implemented. Okay. So we're going to take an action. So that should queue up our draw. And so then here, what we'll do is we will step. We'll call resolve until done or pending. We'll resolve until done for now. This might get renamed and moved around later, but for now we're just going to make a resolve until done. Okay. Resolve until done. And the resolutions should also store the user of it, the person that used the paid ability. So we're going to resolve until done. And then here, user is user paid ability. We just, yeah, it's whoever the announcee was. Okay. Which we should just rename to user. Okay. Right. So we're going to take an action as the corp to take the basic action to draw. So we should end up with one click left immediately. Then a checkpoint happens, but like checkpoints are fake for now. I should add a note of that though. Checkpoint here first though, but later when checkpoints exist. Okay. So we're going to take an action to use a paid ability. Okay. While self dot resolution stack, while let sum resolve equal self dot resolution stack dot as mute. Nope, because we're going to take and put back in. Yeah, okay. I don't want to do this with recursion because it could recurse quite deep. But I do just want to call resolve until done. So I think we'll have a private function called resolve once. And then this will say while self dot resolution stack dot which needs to go till it yields. So I guess we'll just have a loop in here that we'll call resolve once. And then if resolve once triggers a yield, so returns true if resolution if all steps of a resolution are complete. And then we avoid recursion of calling resolve until done again. Okay. Because we can't just check is empty because there might be inputs we need from the person doing things at this point for modal choices and the like. Which, yeah, because you make those when an instruction, it's not an instruction, but it's an instruction, prompts you to make those. So they're not exactly the same as, yeah, as like deciding to use an ability. Although the game does also call that an instruction. The game calls a lot of things instructions that I'm choosing to treat separately, which I think is actually the more sensible decision now the more I've worked on re-implementing this client far too many times. I don't like this though. For now, I'm just going to implement a step resolution. And we'll just call that and see how we go. Okay, so step resolution, match self dot resolution stack dot you want to take whatever's on top of the stack. Do you want to take it off and then maybe put it back on? I think probably, yeah, that's the approach that makes sense. So we'll say here we can return this for convenience. Let next resolution is this. Okay. So then we need to handle that resolution. Okay. And then maybe that is going to push it back on. Maybe it's not. Depends on the ability. Okay, yeah, sure. So if you're using a paid ability, we want to do self. Okay. And now we get a new method on here. Resolve instruction. Instruction usize, game state, and mute game state. Okay. And for an action, we're just going to dispatch that off to the actions. Okie dokie. So there's those actions. Let's talk about resolution. So we care about the instruction, and we care about self, and we care about the instruction. Now, if it's not an instruction that we know about, we do have a base case here, which is to do nothing. So if you say, hey, can you do instruction 4 of this? There's no instruction 4. For now, let's panic. Out unknown instruction resolved for ability for action. Okay. Okay, and so what we want to add support for is basic action draws 0th instruction. Okay. Okay. And then this needs to return an option use size, and the use size is the instruction to jump to. Yeah, so returns none if no further instructions, else returns the next instruction number index. Okay. So we have basic action draw 0. And this thing here, it is going to be the end, so it is going to return none when it's done. But before it returns none, it needs to fire off a draw effect. Now, this is where resolving instructions, you announce targets. Draw has no targets. So we'll need to build in a targeting system here, but that's fine. Targets are just part of the whole pending information system. So the instruction becomes imminent. Yep. Or I guess, yeah, we would just say that instruction 0 is choosing the target, and then instruction 1 is the actual first instruction. Yeah, that's fine. And then we jump ahead to... Yeah. do the effects. So this is gamestate.apply instruction effects. And our instruction effect here is just for the user of this ability to draw one card. That is all basic action draw is. Okay. Okay. I think that should be enough for us to... Yeah, this now returns option of view size. Okay, and now this returns option of view size. And I think that's going to be pretty specific to using a paid ability. So what we'll do is we'll say let next is this. If let sum next equal, we'll say next instruction. So if we have some next instruction, then self.resolution stack.push, resolution step use paid ability, ability instruction is next instruction, user is still user. Right, that should be fine. And then down here, we just say we did everything we needed to do. Okay. I think that gives us a pretty robust step resolution function. Right, these need to be debug. And it's instruction self. Okay. Self doesn't implement debug. Should. Cool. Right, now we can actually go do our test. So we're going to step the resolution and then we're going to look at what's in our hand. So we take the action, we step the resolution, and our hand should have one more card in it. Run test. 1, 2, 3, 4, 5, 6, 7. Hey, look, we drew a card. Everyone celebrate drawing a card. Okay. And then if I just debug this thing, it should have told us that there was no more, that we completed one thing successfully. Nope. With this button here. Yep, we completed one thing successfully. And then if I call it again, it'll say there was actually nothing to do that time, you fool. Yes. Okay, cool. No work. Love that. So step resolution's working, taking action is working, basic action drawer is implemented, and now we have a way to implement actions. So there's how we add their costs. We still need to add credit costs, but we can add a few more basic actions because the basic action of basic action gain a credit is a new instruction effect. Gain. And we're going to make that instruction effect. So we've got a new instruction effect, gain side use size, and this is gain. We'll call it gain credits. It's always credits though. Yeah. For clarity though, we'll call it gain credits. Okay. And then no further actions. Okay, and then all we need to do is go over to gain credits, and it's already complaining us that we're not implementing it. And so gain credits side count is always a thing you can do, that's fine. Yep. So this is self dot no gs dot create and move bank counter. So for count times, create and move the bank counter of a credit that was not created from bad publicity to to side dot pool. Okay, and then we go and we finally bother adding this that I should have added ages ago. Implement side, credit pool location, match self, play area location, play area location, match self, corp credit pool, run a credit pool. Okay, so that means we should be able to take the action to gain credits. That was much quicker and easier to do than it was in the last implementation for adding a new ability. See how it scales when we start adding more. But for now, we should be able to, in our test, we'll take an action to draw and take an action to basic action gain. And we'll need to see how many credits we have as well. So we'll do let credits equal nr dot pooled credits for the corp. Dot let's go implement it. Pooled credits for a side is we want to filter for location is play area location corp credit pool and play area location runner credit pool. Those are the locations we care about, but we also want to filter for obj dot kind as counter. Haven't implemented yet. Let's go do that real quick. As counter as counter filter map filter map. So we want to get the counter. We want to get counter object. We want to get what kind of counter it is. We care if that is equal to counter credit. We don't care what kind of credit though, so we'll use match. Counter credit of any kind. Dot. Right. Oh, can you not? We do that? I don't care if it's true or false. Hate that. this should all just be able to be this. Okay, that's an annoying thing then. So we say object kind dot is credit dot counter dot is credit dot then some obj. Okay. So we just care about credits in the credit pool. That'll get us all of our pooled credits, and then we want to just count those. And honestly, yeah, I mean, yeah. Print line credits in pool credits. So this should say we have 6 credits. Credits in pool 6. Okay, nice. Gaining credits implemented. So we really are just into jamming through all of those basic actions now. So action, basic action. Play is the next one. Okay. So play, when you take the basic action to play a card, you have to say which card you're playing. Is that true? Steps of playing an event or operation. Yes. Part of the activation of this action requires you to declare a valid target. I believe it's fair to say. So we already know our target that we're going to play. That feels unrealistic because in reality, the way play works, because you can have an instruction to play a card as well, which is all this actually fires is the instruction to play a card. The instruction to play a card doesn't come baked in with what you're playing. Neither does install. Neither does. Yeah. Okay. We'll advance kind of does. We'll. I think we'll rip out all of the object IDs here temporarily. They might come back. We'll see. Okay. So if you're going to take the basic action to play a card, what needs to happen? We have to ask you to pick a card from the pool of legal cards, and for the pool of legal cards, it depends on the specific thing you're using. Because yes, okay, so we actually what we do is we fire a play instruction effect, and the play instruction effect takes in a set of cards that you may choose between to play, and all of those are cards that you can afford to play. You can afford the cost of. And more importantly, that have the potential to change the game state. So, what am I looking for here? I was looking for this thing here. Yeah. So that's why it's got all of this text here. Is because that's specifying what you can play. So, this also has a really simple instruction effect of play, but play is not a simple instruction effect. Play needs you to give it an object set. We need to tell it what we can play, which means we can no longer have copy safe instruction effects. So we'll address that if it's a problem somewhere. Okay. So we need to implement instruction effect play. I'll leave that to do for now, but then here, after the instruction to play, there's nothing else to do. So yeah, the the pending thing can just fall off. This is going to have to push an input layer on, though. So we'll talk about input layers in a second. But play, and here we have to specify everything that you can play, because we're generating the instruction effect here, and the instruction effect encodes the subset of legal cards. So what is the subset of legal cards here? It is depends on the side, which is called the user. So if the corp takes this action, and I know these are technically separate actions, but I'm encoding them the same for now. We might have to fix that. There might be some mirror morphy nonsense, but I don't think it should matter because you can only ever take actions in your own turn. So for play, for corp, it is just operations in HQ that they can both afford and that have the potential to change the game state. I believe that having the credits to play, to actually play the event, should be part of it has the potential to change the game state check. So I'm not going to worry about that for now. Well, I guess I am, because I guess I'm calling her to put this here. What am I calling it for? I guess we just have to have because this currently only exists for paid abilities, so it will exist for paid abilities. It will also exist for play abilities, which I haven't implemented yet. We'll get to those. Okay. Yes, this all is making sense now in my head again. I've untangled myself. I think we'll implement this. We'll try and play a hedge fund, and then we'll call that for the stream for today. But it's been a very successful rewrite, and I'm much more happy with how this looks now than I was before. Which is, I guess, where we want to be. So what are we doing? We're doing play. So when you play, we are in action resolution. We create the effect. We're in effect resolution. Okay, play. Well, no, we need to create it in the action resolution. Here. Okay, here's where we were. So for the corp, it is events in your hand that you can play and that their playability has the potential to change the game state. So GameState.objects.values. The filter object. Okay, so we're looking for objects that are object.location.zone. We'll just say for where the object's location is equal to location HQ. That's just a regular filter. So that's our first filter. So you want the object's location to be HQ. And then we can just collect this into the relevant set by, as long as we make our last step mapping the object to its ID, this all is fine. Import location. Okay, so in HQ, object dot as card. So here we'll have to use filter map. So we want the cards object.kind.as card. Gives us a card object. And we care that the card's card type is card type operation. Okay. Right. Okay. Is that not what we want here? Oh, then underscore sum. So in HQ, and then the card type is an operation, and we want the ID. Perfect. That should be the code to get. Okay, and we also care that its playability has the potential to change the game state, and that we can afford it, which is part of it has the potential playability having the potential to change the game state. Or is it? No. Being able to afford it is here. It having the potential to change the game state is separate. Is that true? Every time we call play, we're going to need to test that. I think we're going to just need to write, yes, the playability can only ever fire when that's, but the playability is separate. Yeah, so it is both checks, but we're just going to have to do both checks in quite a few places. Okay, I've solved that mystery for myself. So we also care that we can afford it. So let's go implement playabilities. So we go to lib. Up here, we're going to do pubmod playability. And similar to paidability, we're going to have playability, but playability has card object ID. So this is saying we're using a specific ability from a card. That's what that is. Okay. Now, what do we need on playability? Playability. Okay. So card can have multiple playabilities. Is that true? Cards, events and operations always have exactly one playability. Playability. There's pretty sparse information on them. I don't believe that any card that currently exists has multiple playabilities. I'll just blitz that one into GLC. Question. Rules jailable question. Does there exist an event or operation with multiple printed playabilities? Okay. That's out the way. Okay. Now, much like we did for paid abilities, these are going to have to check if they have the potential to change the game state, which for now they do. We assert that. Now, playability is actually even more interesting. I think only exist on events and operations. But I don't know if the rules specify that. Any ability on an event or operation. Nice. Nice. Okay, they only exist on events and operations, which means that we kind of can simplify our model here a bit, because a playability doesn't ever have anything other than this form. So we can actually just make it pub struct playability. Card is a card. Ability is the index of the playability is that. Okay. No, it's a static ability. Currents are weird. Lockdowns and currents are weird anyway. I believe that is one with 0 playabilities, just for fun. It has a static condition and a declaration. Okay. So has the potential to change the game state is something we'll need to figure out for these. It should usually be pretty straightforward based on each card. Usually we can actually just derive it from the effects of the card, so I'll probably build a simple effect abstraction, but for now, not worrying about that. Everything has the potential to change the game state. Everything is purge virus counters. Okay. Transfer using ability has potential to change the game state. Next, we need to have... what else do we have on action? That's probably a good place to look. So we have cost. Yes, pubfn cost. And so these costs, interestingly enough, only depend on the card, because this is just... Well, no, they can have additional cost stipulations, and this can be modified by static abilities. But that's fine. They're still based on what the card is. We just would need to read static abilities. And like we can hardcode a lot of static conditions. I don't think the whole model of declaration effects is actually that useful to the game, because there's nothing that interacts with declaration effects the way there's stuff that interacts with instruction effects through interrupts. I believe so. These are all the cards, but most of them aren't going to have any playabilities. So for everything that is not Sure Gamble or Hedge Fund here, this has no cost. Well, I guess it's more true to say that it just does not have any play abilities. I'm not convinced that there's ever more than one playability on a card. Yeah, so these actually are just like not a card with a playability. How did this end up in a playability struct? Cool. Okay. Which I should probably, we can copy the thing I did here. Unknown or unimplemented event or operation. Okay. Okay. Sure Gamble and Hedge Fund both cost 5. 5 credits. Cost. Hey, we're going to finally implement credit costs. From static terms. Cost terms. Credits 5. Okay, click. Credits. U-size. Okay. So, implement cost credits. First of all, can we pay them? For this, we'll need to look at what's in our pool. So really what we need is we need to get the sum of our credit costs. So we'll say let mute total credit costs, because we could have these coming from multiple terms and from reductions. We can say total credit. We can say cost terms. If it is a credits cost, then total credit cost has to go up by that amount. And then here, we'll say let has enough clicks is this. And we'll say that can afford credits is total credit costs is less than or equal to game state dot pooled credits for side count. Pooled credits for the payee. Now, there's obviously yeah, there's obviously recurring credits that can be used to pay for costs. And when I add a card with those printed on, I'll modify this here. Need to also check static declarations, declaration effects for sources of credits from recurring credit cards. Okay. Is that not just... Is there any meaningful difference between that being two play abilities? So the card Big Deal has been brought up for reference. Is there any meaningful difference between Big Deal having two play abilities versus it having having one with 3 inch, one with some more instructions to RFG the card tacked onto the end? Because it's feeling to me in my soul that events and operations always have effectively one play ability. Yeah, for now, we're going to ignore the idea that there can be multiple play abilities on a card. I reject that. I think events and operations always have one play ability, and if their card is formatted to imply otherwise, the card's formatting is just for visual clarity and not for mechanical reasons. Okay, and can afford credits. Okay. So now we check if we can afford to pay the credit costs of a card. Love that. For us. Okay. Where was I? We were on here. Pay. Okay, so paying credits. So paying credits is more complicated because you have to choose which object you want to get rid of. So a thing has to go on the resolution stack. And whatever's currently on the resolution stack kind of has to get suspended. Because if we look at where pay is called from use PA is called from take action. Take action, we're just manually invoking right now, but it's like when you take the play action, you're going to have to call pay. We're going to call pay as well on cost. So that's a way that a cost can happen outside of the action cycle, which means it's happening during resolution. So we need a way to kind of say, hey, this payment needs a specific finite set. We could ask you to provide that object set here. And I actually think that's probably the solution. I think we probably say payment object set. Because most payments, if they resolve a thing, we just resolve the thing as part of payment. And if there's decisions there, then cross that bridge when we come to it. Okay. So yeah, I think you just supply your payment object set as an object set, and then we look through your payment object set, and your payment object set is here are the things I'm happy to lose to pay for this, and we just bop them off. And much like here, how technically it let you pay saturating, so like if you went to 0, it would just keep going to 0 because you should be calling can pay before you call pay. It's the same thing here. Can pay needs to be called, and then we just trust that you're passing in an object set. That doesn't feel right. Can pay needs to be called with a specific object set that it's allowed to look through to see if those are legal targets for payment. Yeah, so you pass it the set of objects that you're willing to lose. And each object set can pay for a single thing, such as credits. Yes. So instead of looking at your pooled credits, we have to look through the object set here. And we need to check that it has exactly the same number of credits in it. And that every counter has to be used exactly once. Okay, I have now got an idea of how this needs to work. So clicks is simple. For credits, what we actually need to do... so for this here, you would just... That's part of determining what you can pass into the object set, which we'll do in a bit, but not worried about that for now. Yeah, so you have to always call can pay and then call pay. Otherwise, I guess we technically just do that here. We say self.canPay, if self.cannot pay, return without doing anything. But pay, we'll just return false. And this can return a bool of whether or not it was able to make the payment. And then the place where we call it here, we can say if pay, then do that. Otherwise, just like fail silently. That's fine. And this needs an object set. Yes, so we actually need to have a way to determine the required object set for a payment as well. You need to be able to provide payment candidates. Yeah, paying is complicated, isn't it? So does payment... When you pay, you have to give it your objects. These are the objects that you're happy to lose alongside your clicks, right? As part of any, like, thing. So really what we actually need here is cost terms. Credits is always just credits, so that's fine. Yeah, so you'll have to find legal options that are currently available for you to spend. Do we want that to be caller responsibility, or do we want to have that to have an in-can pay? It's caller responsibility because you can choose whether or not you spend them from bad publicity and what have you. Payment actually just needs to be its own resolution step, which I think I knew from the last time I built this system. So when you call pay, it should throw on a new resolution step. Yes, okay, I see how now. So basically, wherever we call pay here, we're always going to be using pay to justify putting some other resolution on the stack. So instead, we should put a pay step on the stack, a pay step with all of the specified requirements for that payment. That then has to be fulfilled as part of a non-step operation in order for it to progress. Okay, yes, I follow now. So pay actually needs to be refactored a fair bit. Because what we actually want to do here, when you use PA, is we want to do self.costs. So that gets us our costs. And then we want to say dot payments for, and we'll say as payment for this resolution step. Okay, and we want to do push that. Yes. So does that feel correct? Yeah. So this is kind of what the API actually needs to do. We want to say, what's the problem here? That closes that, that closes that. That, okay. As payment for doesn't exist yet, but basically we're going to get our costs and then we're going to treat them as a payment for this. This is going to create its own resolution step, which will be our second one, which is called make payment. Make payment is going to have a it's going to have a few things to it. It's going to have after paid, it's going to have a new resolution step that has to get put on in its place. And it's also going to have, if unable, it's going to have a resolution step. Well, hold on, it's going to say if the payment is optional. So whether or not it's a mandatory payment, it's going to have a when paid, and then it's going to have a when declined. I'll say when unpaid. And so this is, what does it do if you pay? And what do we do if you don't pay? Can this be multiple steps? It can. So they should be in vec form as well, and we'll join them to our existing vector. I think for now we'll do it a single step. We can update that later. Okay. So here, where I created that as payment step that was kind of fake, nope. Let's just go find wherever these errors are. This thing here, we'll just comment out for now. Okay. Yes. Okay. So here, next resolution, we match the next resolution. Here we need to be able to handle those. That's fine. And then here we have resolution step. Right. These need to be behind a pointer. It's fine. We can just stick them behind a pointer. Okay. Now, as payment 4 doesn't exist, because what we're going to push is we're going to push resolution step, make payment, and we're paying, it's mandatory payment. If you're using a paid ability, you have to pay for it. When it's paid, we use the paid ability. Okay. If it's unpaid, what do we do if it's unpaid? If it goes unpaid, we this is why we make these optional to start with. Okay. These might evolve into something a bit more complex later. Okay. And then we have costs. We have a cost for our payment. And the cost of using a paid ability is always the cost of that paid ability. Kind of goes without saying, but you know, we will need to add that in cost self.cost. Okay. That's what using a paid ability actually looks like. When you use a paid ability, you make the payment. Okay. And now we have to implement the resolution step for paying a cost, which is our first proper input step, right? Because it needs the caller to make some decisions based on the information present. So to make a payment, first we need to know whether or not you're declining it, if you can decline it. So, yeah. Then we need to know. So then we'll do what you do when we pay. Okay, so really here, what we need is we need something in our game state that we can use to know. We'll call it the inputs here. So yeah, I think here step resolution just needs inputs. Step resolution inputs. So this is how we're going to inject into the system. This here needs to be more complicated, which is annoying because it's nice being able to have this thing here. Because we now we don't just have none remaining. We also have, there is some, and I guess we can just change what's in here. Yeah. So here we'll say, I'm just going to make a new type somewhere in this file. This file's getting a bit too overloaded, but pub enum resolution. So either there's no resolution, or there's some resolution, or we resolved, or waiting for input. So this returns a resolution status. Okay, and we're also I'm going to make a resolutions folder, a resolutions file somewhere, but for now we already have one, right? Yeah, here. Okay, cool. So resolution status, we have resolved and waiting for input, and then we also need to have a resolution input, which has got no input and has got our input that we need for a specific thing. So yeah. I guess probably here we also want to have pub enum resolution input kind, because we're gonna have different kinds of input. Yes. So you can say what kind of input we're waiting for. Okay, nice and simple. Now we go back to our resolutions. In here, go to our error. So here, we're first going to import resolution status, and we're going to input resolution input. Okay. But I honestly think we should probably just not do all this in here. This should be over in resolutions. Let's pull this out. So this here. Yeah, from here onward, we'll do next resolution dot resolve with inputs self. Implement resolution step. FN resolve with. And what do we call this with? We called this with our inputs and our game state. And this needs to return resolution status. Match self. And then this is all game state interaction stuff. We need self here. Okay, yeah, and now we have to dereference stuff. All right, no. Next instruction. What's your issue? Expect paidability found and paidability. What's your issue now? Oh, yeah. Okay, let's just Are we? We're not easily clonable. That's annoying. Ability is and user is though, so we'll just do that. Okay, there we go. Okay, so that's that pulled out. Okay. Okay. And then we're going to step resolution for our resolution input, which for here was no input. Okay. Still fine. Okay. Okay, that's that done. So now we just have to implement this, and that's cost paying that. Oh, I was really bold when I said let's do playing a card and call it. But I really want to be able to play a hedge fund. You know, when you just really want to play a hedge fund. Okay. So, making a payment. First of all, we need to check that you've given us the right input. So we're going to say if let resolution input make payment. Okay, we'll just keep jamming stuff in here and we'll remove it when we can. Okay, so if make payment is equal to input, okay, actually we'll do let else return resolution status waiting for input resolution input kind make payment. Hold on, what have we got here? So this. Okay, there we go. So now we've got a guard and we say we're waiting for make payment if we're not receiving make payment. So that's that part implemented. And we can put whatever spec we want in here for the payment itself, which we probably want to do. In fact, yeah, we probably want to say what the cost is. Because the cost, yeah. So here we'll say we're making payment and it has to satisfy cost. Which means we lose copy on these, but that's fine. Cost can implement debug, that's fine. Okay. Problem? Eck. Partial eck. Hash. Clone. All of that on cost terms as well, please. Cost terms can also currently be copy. Don't know how long that'll last, but can for now. Okay, that's that done. Make payment of cost. Okay, so now we can just clone the cost. Okay, so now if we try and progress with make payment and there's no make payment available, okay. So now by the time we're here, we know we have an input. We can specify what that input is. And what the input needs to be is it needs to be a satisfactory object set. So part of our make payment input needs to be object to spend object set. Which means we lose copy, which we were always going to lose. I was not expecting us to retain copy on this. Okay, so now we have objects to spend available. And we can check if the cost can pay with our objects to spend. We need to encode the side in this question mark. Do we not already have that somewhere? No, we have the user. Okay, so here we also need to encode the payee. It's part of make payment. And so payee is side. And then when we initialize it here, payee is user. So if that payment set doesn't satisfy our costs, then we return insufficient input. We'll just return the same thing again. Hey, you need to pay us this. You're not doing that. Try doing that. Yeah, because then you could just round trip it and check as often as you need to see if it's being fulfilled or not. Yeah, that's fine. Okay. So we're going to return, so if they can't pay, We're still just waiting for you to pay. Still ain't paying. Consider paying. Okay. Then, if we can pay, well, payment might be optional. So what we'll do here is declined is a Boolean. So we can say in here we also have declined for if you decline to pay. So we can say if declined and optional, then we're fine. We're done, right? You don't need to give us an object set. You declined the payment. You know what? Maybe there should be a separate input called decline payment. Nah. So if you decline and it's optional, payment declined, do when unpaid things, which looks like game state dot resolution stack dot push when unpaid. When unpaid is an option. If let sum when unpaid is equal to when unpaid, so if you declined and it was optional, gs.resolutionstack.push when unpaid. Just clone it. Don't mind me doing some very ugly code here. It's something like that. No clone found for resolution step. Hey ho. Resolution step. You don't have anything in you that can't be... I just want to move out of you, right? And we can just be self. Like, yeah, I kind of want to move out of all of these. But then if we fail, we've moved, which is the problem. So we don't want to do that. We do just want resolution step to be clonable. Okay. It's already clonable. It's already clonable. No problems. Because we're a virtual machine, it should always be clonable now, rather than the whole thing I had before with complex object state. Okay. Then when unpaid comes into it, and we return resolution status resolved, because that's all you need to do if it's optional, and you declined it. Okay. Then we need to, if they're not declining it, we need to check if they can pay, which we do here. If they can't play, we kick them back with the cost again. I guess technically we want to tell them the cost and tell them if it's optional. We'll do the same here. Okay. So, if they didn't give us an input that was a make payment, then we tell them we need to make payment. If they declined, then we push whatever happens when you decline, or unable. Rules jailable question. Is there any card that has 3 effects? One for if you pay, one for if you don't pay, and one for if you choose to not pay. I don't think there is, so for now I'm going to assume there isn't, but there might be. So if you can pay using that... we're going to need a way to check that there is no legal way for you to pay as well. which I guess we just do by punting every object you control into the set. Yeah, so if you provided an insufficient payment, then we go here. Otherwise, we have to check. You gave us an insufficient payment set. Are you actually even able to pay for it? Needs to happen. So I guess actually what I should do is I should check if you can pay. And if you can pay, we'll return resolved. I'll say, we'll do this. Yep, so if you can pay, then we'll do cost.pay using your objects to spend to make the payment. Okay, so that makes the payment. And it's just always going to return true, I think. We'll just assert it. Okay, so we're going to pay. I mean, this is just calling can pay immediately. And payments are always going to be part of resolution, so we don't need to do this anymore. We can actually just remove the whole return from this. This method just needs to actually make the payment. Okay, so we'll pay. And then after if we can pay, and then if we can pay, when paid, okay. Then we do whatever we do when we're paid. Nice and straightforward. Wait, we can take. Right? No. Okay, we clone. We clone. We're fine. We're fine cloning. Okay, so when paid becomes the next resolution, and we resolved this one. Okay, if you could not pay, we need to check if you're able to pay. Check if able to pay at all. If you're unable to pay for a cost, then we need to also do the when unpaid. We should just have a when unable, shouldn't we? They can just be the same a lot of the time. When unable, option box resolution step. And for anything that should never have that happen, it can just be none. Just do nothing if it's unable to be paid. We have when unable here now. Okay. And then in here, when we use a paid ability, because this should never have been called if we couldn't afford to do it, it's when unable is also none. So doesn't do anything if we decline the payment, because it's this shouldn't be optional. This should be non-optional for using a paid ability. You have to make the payment as part of using the paid ability. Okay. Okay, when unable is our new thing. Right, so here we need to check if you're able to pay at all. So how can we do that trivially? We just supply every object that you as the payee control, right? Because you can always make a payment with an object you control. Well, no. Only with credits, you can only do it if they are in a relation, if they're on a card that says you can spend them. So the credits is just we send every credit in your credit pool and see if that would be enough. And we send, yeah, for now we just send every credit in your credit pool. In the future, we'll need to add more objects to the universal check. So here we're going to say if costs can pay, so if not costs can pay, and we're going to build a new object set. And this object set is going to be game state dot objects dot values dot. Okay, hold on. We'll say let all objects payable equal gs dot objects dot values. Okay. Dot filter. So we can start by filtering for where the payee is okay. Payee here. Yeah, so we can start by saying we're going to grab everything where the payee is the controller. Is some payee. Okay. Then we can filter it even further because we only care about the objects. Filter map. For the cards. Sorry, for the as counter that are so as counter dot is credit. So we care if you have a credit. We're going to just create a big union here. So we'll say all spendable credits is going to be filter map. So we want to get credits. Yeah, we're just going to, okay, hold on. We're going to say let object.location. Yeah, okay. We'll say filter object.location is equal to payee.credit pool location. And then we want to do that. Okay. So yeah, we want all of the objects, all of the object IDs for objects that are credits in the credit pool, and we will add in other payable locations later. There really should be some function that is just get me all of the credits that are spendable. For now, we're just going to use this. So all spendable credits. So that's our current check set. So if you can pay using all of your spendable credits, and if you can't pay using all your spendable credits, then we need to do the when unable. Okay, that is payments written. I believe that is cost payments done there. So now we just need to tidy up this bit here, which is how do you actually pay a credit term, and how do we determine if you can pay a credit term. So so this is where we actually need a game state for currently spendable credits. Yes. And it also needs to tell you, because if we look at recurring credit cards, right? Let's go over to Netrunner DB for a second. So if we look in startup for how are we going to search recurring credits? Recurring. Okay. So Jezva is easy. It's just checking the game state to see if we're currently in a run on a central server. Perisha. It says trash cost of assets. I'm guessing this means you can spend hosted credits to pay for the basic trash ability. I think. Aha. when paying any cost that refers to an asset's trash cost, including the basic trash ability. Okay. So that's just going to need to be a bit of metadata we pass through. I mean, it's system update, so it's going away, but like, you know, in principle, we can spend hosted credits to pay trash costs. And it's literally just to cover the new wording of this card here, which is this accessibility, pay the trash cost of the card you are accessing. Okay. So that thing there is like an X, and this can be used to fulfill that. That is a whole separate system we'll worry about later. Okay. Prepaid voice pad cares about playing an event, but it's not the basic action to play an event. It's any action that would let you play an event. But I think the only action that lets you play events is the basic action to play an event. We'll figure that out. And then Scrubber is also trash costs. So we have trash costs, we have play events. Okay. Jezva's a lot more straightforward. You can spend them during a run. Let's look in all of Standard. So in Standard, we add in this. Use these credits to res ice protecting this server. Yeah, so that's part of paying your res cost. Okay. Well, that we can work off the cost type, which is a whole system I've not bothered implementing yet, but cost type is a thing. It's information that's tracked as part of the cost. To use hardware and programs, so we can only spend this if we're currently in a resolution to use an ability on hardware or a program, because that's what counts as using, I believe. I guess, no, using has weird definitions. Hold on. Using a car. Considered used. A paid ability is considered used. A condition ability is considered used, so you could use it to pay for a cost during a conditional. An ability allows for move kind of the business cost considered used any time spending. Okay, yes. The use is a bit vague, but I think I know what they're getting at here. Well, it's not vague. The rules are specific, but the wording, the way it interacts with this is something I'm going to have to think about more. During runs, nice and easy. And then pretty sure we've seen. Okay, I think, yeah, for now, we don't have any recurring credits in the game, so we don't need to worry about this, but it's good to kind of mentally factor in that that's a thing we'll have to do eventually. So we can pay if our total credit costs are less than or equal to our payment object set dot I guess we're going to need to go through this, and we're going to find all of the ones which are credits. Right, this was the whole thing, is each object can only be used once, right? You can't use an object to pay for one thing and another thing if there's multiple cost terms. But credit counters can only be used to pay for credit costs, because there's no costs that say a counter. They always say a credit counter. So I think we should be fine here to just say payment object set dot iter.map gs dot objects dot get obj dot filter obj dot so obj here is right, this is filter map, and now object is actually something usable, I hope. Object dot, is object still an option here? Object is an object, good. Object dot controller is equal to payee. Filter for object dot kind dot count is counter as counter dot dot is credit. And count. Okay. Okay. So that gets us all of the credits in that payment set. In reality, I'd like to iterate over this and have it add up a total credits in set and then compare those. That's actually what we should do. That's actually what we should do. We should do for object in payment object set. It's just what I'm doing here. I'm just doing it differently. We'll just leave it like this for now. Okay, so can afford. So we can afford if our total credit costs are less than or equal to all of the credits provided to the payment object. Yes. Yeah, no, we don't prevent cheating here, so we don't actually care about stopping you from spending the other person's credits if you're trying to. Well, we will eventually care about cheating here. That should probably still be disallowed. But then this also needs to check that they're a subset of the ones in your currently available payment set. So yeah, available payment set of credits is a thing we need to build. Not going to do it now. For now, I'm leaving it like this, but we're gonna put that right at the top of our to-do for next time, I think. Okay, so then when you pay credits, we have count. We need to eliminate that many credits from our payment object set. And so these are essentially a set of objects that it was fine for us to lose. So I think we just say for object in payment object set. Count here is a usize, so we say let mute paid credits. So for everything in our set, game state dot move object to the bank. Because it's only credits right now. We're going to have to rework all this once we have non-credit objects. Okay, so that's just going to rip through our objects, trashing some set of them without a care in the world. And if we run out, so this actually should not break. This should just, yeah, this should break. Yep. Okay, so if our paid credits is ever greater than our count, then we break out of this loop. And then here we can say if paid credits is greater than or equal to count, then we're fine. If it's less than count, so if we reach the end without paying everything, then something went horribly wrong. But we don't care. Because this thing doesn't care about checking if you can pay. This thing just cares about doing as much of the payment as it can. Okay. So that's payment done. Are we done? Can I just like because take action puts the payment on the stack. Yeah, so if I do this and I say no input, what's it going to say to us? I'm hoping it's going to tell us we want a payment. Make waiting for input, make payment, waiting for input, make payment. Okay. And they both cost a click. Okay, so let's make the payment. So instead of inputting no input, let's input make payment. We are not going to decline, but we're also not going to give them any objects to spend because they shouldn't need any for either of these payments. Okay, so now that that's done, this should be where we were before. Oh, we made a payment. Resolved. Okay. Right. Okay. Yeah. But after you, so we have to do that, and then, yeah. So we make our payment, but then we need to step the resolution again with resolution input, no input to say, hey. actually do the thing we've just paid for. And again, whatever controls timing structures will control these. Good, that gets us up to 6 credits. So we resolve no input, resolve no input. Okay, nice, we resolved both of those. So we should be at 6, right? We gained 1. We should have 7 cards in our hand. 1, 2, 3, 4, 5, 6, 7. Okay, we're going to take our final action. Our final action is going to be playing a hedge fund. And then we're going to call the stream. So let's do that. So let's plug this in. So nr.takeAction, side is corp, action is basic action play. And then we're going to step that resolution with no input, and we're going to see what it says to us. A bit of test-driven development here. So it says, when we stepped with no input, it says here, waiting for input, cost of a click. So this is paying the click to actually like take the action to play a card. So let's make that payment instead of no input. And then let's give it no input and see what it does. I'm hoping somewhere it's going to panic. Nice, panicked. So we resolved our payment of the click. But then when we got here, we got to the instruction effect for playing a card. We failed because we need to push a new resolution on, which is the resolution to, you know, it is the... Oh, wait, hold on. No, this is play. Right, play has been given an object set here. So this is cards. So if I go here and I say print line, debug print cards, and we run this, it should be at the point here where we have a list of events in our hands that we can play. Which I can do by clicking the test button again. Okay. Yes, here. Right, because I removed the to-do and replaced it with a print line. And so it says we have 1 object in our hand we can play, which is true. It's just the hedge fund. And if I run it again, hopefully we have more than 1. So here we just had 1 again. Let's run it again. I'm hoping to see more than 1 hedge fund in hand. Oh, just a lot of Palisades. Can I have multiple hedge funds, please? Okay, so here I have 3 hedge funds in play, and it's offering me 3 cards I can play. Okay, nice, that's working. So we get here, and we know all the cards we can play, and we need to just add the resolution step of asking the person to choose with the follow-up of it being the actual card being played, which is to resolve its playability. So, okay, so what we're doing here is we are creating a new state. So gs.resolution stack.push. Okay, and we need to push a new resolution step, which is choose play card. We'll call it choose. We'll call it choose object. So this is for when you need to choose a single object. Okay, and the set is the object set. Okay. And then so we have choose single object, optional. No, so then we have object set, and then we have when chosen, we're going to need to do something with that chosen object set. With that chosen object, we are going to need to do a new box resolution step. So for this is for choose an object, choose single object. Okay. We'll call this choices. So really we could make this more generic for choosing between any number, which we could then use as part of having people pay costs to say, hey, choose which credit counters you want to lose. So you can choose between your cards on hand and cards on bad publicity. Not worrying about that for now. For now, it's choose single object. This might become choose objects and be a bit more sophisticated later. And then when chosen, we're actually going to need another new resolution step. Which we are going to call so this was the play instruction where we had a whole thing and you had to choose one. After your play instruction, then we have what do they call it in here in the rules? Steps of playing an event or operation. Place the card face up into the play area. Pay the play. Okay, so it's this here, which is which we will call wait, wrong screen. Oh, you've been looking at my web browser for a while. That's fine. You're all just listening to me talk in the background anyway. Place the card face up into the play area. It is not installed or active. Yeah, so we call this begin play. Hate that, but yeah, cool. I'm being too generic. We make this simple. We make this even more sophisticated. Instead of choose single object, this is choose play card. And all you have is an object set, and the only thing it's going to do is put it into play. Choose play card. Choices. Okay. Now we have choose play card. We need to add in the resolve with. Okay, so we have to come into our match statement here. Because we've got use paid ability, we've got make payment. We need to add in our new one. Which is choose play card. Okay, so for choose play card, it's going to be pretty similar to the previous one. We're going to say choose play card, chosen object ID. Okay. And our resolution input kind can be choose play card, choices, object set. Cool. So we say let so what do we do here? We're saying yeah. So we're gonna say let resolution input choose play card. Chosen is our input. Else return resolution status, waiting for input, resolution status, choose play input, choices. Okay, so if you don't make a choice, here are your choices. Then if choices dot contains chosen, so if not choices contains chosen, so if the thing you chose is not one of your choices, then also do that. Just, you know, hey, you got to choose one of these, bud. Okay, and then if we can make it here, we know that you've chosen something called chosen and that it's in your choices that were legal, so we're happy, and we put it into play. Which so I mean, so here, use paid ability, this is where we put the use paid ability step on. I think we should just put a new step on here. In the same way that the outcome of this one was just putting on the when unpaid stat thing. Yeah, so we need to put on a new step. And the new step is the one that actually plays it. So here we're going to say gs.resolutionStack.push. Resolution step dot. So we've done choose play card. So we're actually going to just do, in the same way that here you had use paid ability, we're going to have play card. Okay, and then the card is going to be chosen. So the card is an object ID. And then we just do all of the playthings with that card. Like, well, hold on. Yeah. So playing it, part of play card is going to be putting it into the table with play the cost and then fire off its playability. Yeah, it becomes active, which is when all of the static abilities that are on it become active that were not already active. We're going to talk about a card activity and ability activity later. I guess, yeah. Okay, so play card goes on the resolution stack. That gives us a new thing we can resolve here called play card. Feels a bit silly putting something on just to have it come off immediately, but that's essentially what we do here. And I think we shouldn't because we already know what card we're going to play. The only reason that this has to put something on the resolution stack is because it's kind of got it held in cache ready to do. To the extent that maybe it should put it on the stack and then it should just immediately recurse with no input. But we don't know the next thing isn't going to need input. The next thing could be another input decision. So yes, this does need to go on the stack again. Here with play card, it doesn't, because play card, we know what happens when you play a card. That's like well understood. Yeah, so we're going to get rid of play card. We don't actually want to have that be its own thing, because play card is always going to involve choosing play card, even if there's only one choice. Yes, okay, cool. So once we're here, you're fine. We're happy. Time to play the card. So game state.move object. So we have to move the card. So chosen to location play area location unspecified. So it goes into the play area. Face up. So we do gs.objects.get mute chosen dot expect. Well, this here gives us, so let chosen equal, there you go. We've got to remember that because it moves. Expect played card stopped existing, question mark. Yeah, playing non-existent card somehow. Okay. So we're going to say let object equal that. Okay, so now that gives us our object with all of its metadata. So we can say it's we actually need its kind information, so we'll do .kind. We'll call this card. We'll say .as card .expect playing counter somehow. Playing non-card counter object. Okay. So now we have a card here. Wonderful. So we can say and should be mute. As card mute. Time to add that. As card mute. Okay, now we have a mutable card. So card dot, it is face up. But it's not yet active. Okay, so yeah, a card in the hand is neither face down nor face up, so that's why setting it to face up is important. Really, we should just have active on here as well, which defaults to false. Oh, right, hold on. Play resolution stack cards. dot clone. Okay, that's that done. So it goes Facebook into the play area, and then you have to pay the cost. Yep. Any when played abilities. Okay. Yeah, so you get a checkpoint here for cards being played, but we're not worrying about checkpoints yet. Put card played checkpoint here at some point. Cool. We need to then resolve the playabilities of the card. Well, no, hold on. We pay the cost. We pay the cost, and it's the cost paid checkpoint is where this thing happens. Oh, you have another extra checkpoint. Okay, so you get the cost paid checkpoint, then the card becomes active, then you get your when played checkpoint. Okay, cool. So yeah, here we're now on to gs dot resolution stack dot push resolution step make payment. It is a mandatory payment. The cost is the cost of the card, which we're going to need to just have available. I'll just say card.printed cost. Oh, no. We'll just say card.play cost. And that should be something we can compute from the fact that it's a card object by looking at static abilities that affect it and its printed cost. So I think we'll just do that. Pub.fn play cost. Self returns cost. Match self. Match self dot card for now. Okay. Now play cost only applies to Sure Gamble and Hedge Fund. So for these, we will just panic and say no play cost exists for non event / operation card self.card. Okay. Card. Okay. That's that done. Sure Gamble has a cost of didn't I write these somewhere? I did it in like playability or somewhere random, didn't I? Yeah, okay. Screw everything I did here. Do we even use playability anywhere? Hold on. I didn't add any more errors to the code, so probably not. We'll delete it in a sec. Sure Gamble cost, well, it'll have to come back in a second, but for now we're gonna put should play cost just be on playabilities here? I think no, we should use this. We wrote this. This is here for a reason. Let's use it. It's also where it also makes more sense to put stuff there. Yeah, okay. Go back to object. Let's not add specific stuff to object. Let's go over here and we'll say playability card dot cost. Okay, so that gets us our cost. Our payee, we needed to encode in who was making the choice. So this is now our side dot. This is now our chooser. Okay. And then nothing if you don't pay, nothing if you can't pay, because you should only reach the state if you can pay. Yes, okay, and then when paid, this is where we have to put the rest of the play sequence. So yeah, so you put this in, then you're prompted to pay for the card. And then we're going to put in a sum box new resolution step. Now we do need a new resolution step because it comes after a payment. And we'll make this one card played. Yeah, because it's also going to fire off our when played. And the card is going to be card dot. The card is going to be chosen. You still have access to that information. Okay, and so now we add a card played. That feels a lot better to me. Card. Okay. And it's an object ID. Okay. So now we can add in what happens when a card is played. So when a card is played, checkpoints we're ignoring, resolve the playabilities of the card. So here is where playabilities come in. Playability, card. Really, it should actually be, we'll say, let playability equal this. And then here we'll do playability.cost. GS. And then here I actually want... No, it can... We'll just do it like we were. It doesn't matter. As long as this remains cheap to create, which it should. So playability card should be all we need to create the playability. We will have already checked that it has the potential to change the game state in a future version of the code where we care about that. So having a playability should be similar to having a paid ability object here. And we had a use PA, and here we should have a... You use a payability, you resolve a playability. Resolve instruction, yeah. Okay, so we're going to say... I mean, really, we're just doing... It's more resolve instruction stuff, right? But resolve instruction... Yeah. It's just more resolve instruction stuff with multiple instructions. So the playability can have any number of instructions. That's what we figured out. So it's just pubfn resolve instruction and self instruction usize. Same way it was on paidability. And we don't even need to know who the user is because it's just the controller of the card for playabilities. No one can play an ability that isn't the controller of the card with the playability printed on it. So that shouldn't be an issue. So resolve instruction. And we need the game state, obviously. Okay. We're getting close to being able to play a hedge fund. Why do I feel like resolve instruction on paidability had something else going on with it? Yes, okay. Next instruction for the use paidability needs the same down here. Next instruction for the card played. So, next instruction is this. Right, okay, yes, but it's not card played, it's it's resolve playability. So we need another layer. Too many layers, okay. So here what we want to do is we want to say yes. Well, card played will eventually need to exist so that we can invoke this checkpoint, but for now, I think we're changing this to resolve playability. instead of card, it's going to contain a play ability. And it's going to contain an instruction pointer. Same way we do with this thing here. And it might as well also have the user, the player. Yeah, this is actually a player, as in the person who plays. Okay. Playability is not clone. It should be derive clone. You can be all kinds of things. Copy, clone, everything. Okay. So then here we want to do playability card.card. Wait, but we need to trash the card at the end, so we do actually still need it to be a separate thing. Okay, I follow. Yes. Okay, so resolving a playability has two parts. It has the part where we put the after it, yes, okay. Yeah, so let's wind it back a bit to where we had card played here. So when you play a card, we're going to layer on top of it, resolve the playabilities, and then when those are done, we need trash card to be there. So after you resolve checkpoint, yes, so then this is the post card played. Okay, so this is actually kind of fun. So what happens is when a card is played, now we've already removed it by the time we call resolve with, because we start by popping from the stack. Yep, we know that. Okay. So we have card played and we have post card played. In card played, we're not doing that. Card played is going to do, and we also need a resolve play ability. Play ability, instruction usize. This is going to be very similar to our thing here. And player is side. Okay. We can jam side back into these if we need. Probably. We'll just... It's good to not throw away information as we go. Okay. So now here we have player and player on these, and we have a new one for resolve playability. Okay, so when a card is played, what we want to do is we want to do game state dot and so this is after the payment, right? This is the thing we're putting in here. Card played. Player is chooser. Okay. So we're going to do game state dot resolution stack dot push. We're going to push on the post card played for the same card and the same player. And we're going to we have references, card and the same player. And we're going to follow that immediately by pushing the resolve playability. And the playability is playability. What's card here? It's the object ID. So we want to turn that into something. We can do that with this whole thing again. Okay. So there's the card. The instruction is 0, and the player is the player. So then this is on top of our stack, so this will resolve fully, and then we'll hit the postcard played when this fully resolves. Okay, so steps of resolving a playability. Maybe we should have the same instruction nonsense going on, because this pattern of instructions is really common and has some common traits to do with when checkpoints fall. For now, because my goal is to finish the stream today, and finishing the stream involves letting us play a sure gamble, I'm not going to do that abstraction. We're just going to keep instruction resolution as being what it is currently, which I can pretty much copy paste from what we did in use here, which is this here. So we say let next instruction is ability dot resolve instruction, which might as well take player because we've got the information available. Use resolve playability. Player for player. Okay, so if we get a next instruction, then we push it. Otherwise, we churn through. And resolve instruction for these ends up looking pretty similar to what we did here for the cost. But instead of it being resolve instruction needs to return something, it needs to return option, right, it needs to return the next instruction pointer. And if we hit the end, then we just return none. There is no next instruction pointer. Okay. So we have sure gamble and we have hedge fund. And this is our effect implementation. So if we look at our paid abilities, we can see how we did these. We did it with resolve instruction here. So we looked at we looked at what the action ability was, and then what the instruction was. Yes, okay. So what we want to do in our playability is we actually want to match over card and instruction. Now these are both single instructions, so they're nice and straightforward. Did I return none on every branch? It feels like I did. Hold on, action. I did. Okay, let's do that then. It's more explicit. Okay, so sure gamble, instruction 0 is, and this is just an instruction effect producer. It is apply instruction effects, gain credits. For the player, 9. And then the exact same thing for hedge fund, because they're the same card. Okay. Okay. Okay, there we go. That's all that written. Okay, and then we just need to write the postcard played. And so postcard played, this is the rest of this. Trash the card if it's still in the play area, so we know our card, so we can just do this we can do gs.trash card. Straightforward. Okay, and then that's it. Okay, so what do we need to see in our test? We want to see that we're gonna do all these actions, then we are going to do the basic action to play. We're gonna make a payment. Okay, I'm hoping it's giving us a choice of things, and I'll figure out how we're gonna figure out what we do with that choice. So let's see. So we run the test, and we are given, we had 2 hedge funds in our hands. Make a payment resolved, make a payment resolved. Okay. Basic action play, make a payment resolved. So that was that make payment. And then I called no input to resolve Nothing. Okay, let's just call no input again. Okay, here we go. Choice is none because there's no hedge funds in our hand. So that we would have been stopped from with NKIGs if we had NKIG support. We now have 2 hedge funds in our hand, so we now have 2 choices. Okay, so let's make those choices. So we can see what we get back from here. So this here, we can say let playables equal this. So now this here, we'll say let some waiting resolution input resolution status waiting for input resolution input choose card resolution input kind, choose play card choices. So this is going to get me my choices. Else panic no available hedge funds. Okay, so equals do no input. Okay, so now that's going to give us our available choices, and then we're going to say something. So this is something went wrong, and then we're going to say if choices.is empty, then we're going to say no available hedge funds. Okay, and then after we go through and see if we have available hedge funds, we are going to make one of them. So we will do choices dot choices dot val iter dot next. Okay, here I can do expect no available hedge funds. Sure. So we'll say let hedge equal this, and that should be an object ID. That is an object ID. Okay, nice. And so we can say nr dot step resolution input choose play card chosen is hedge. So that there is our chosen hedge fund. And then let's just do another no input. We'll do a few more no inputs to see what it wants from us. So it says make payment resolved. There were some hedge funds in our hands. Right, I didn't debug this. Let's run that. Okay. So there's hedge funds in our hands. We've chosen one of the hedges. And it gave us back none? What? Okay, hold on. I think I might know. So here where we put in... Right, because it's popping the layer. I see. So step resolution here. This whole thing where we pop it off. We do this thing here with resolve with. If resolve with doesn't come back... Okay, yeah. So we do resolve with. And we say... Status is this. And then we say match status. And if status was waiting for input, then what we want to do is we want to do next resolution dot push. We want to put it back on top because we're still waiting for input. So we'll say self dot resolution stack dot push next resolution. right? Because if we're still waiting for the input, then we want it to be back on top. And then we'll return some at status. Other side, status at, all of that. So what we should actually do here is we should do it as an if let this equal status, then put the status back on top, and then return some status. Right, yeah. We don't actually care about the status here now. Cool. So, if we were waiting for the input, then, which means this should be a matches, if matches status waiting for input. Okay. Then we put our next resolution back on top. Now, this does mean resolve with has very strict rules on how it needs to behave, which I don't like. It's very non-local code. We should fix that at some point. But basically, it's just that you should not interact with the stack unless you're going to have a good resolution status, which I think is completely reasonable. It's an invariant. We'll just need to make that invariant a bit more strictly maintained to avoid bugs. But that sounds like a next time problem, because this time we're trying to play hedge fund and not have any issues. So where do we get to? We get to waiting for us to pay 5 credits. Nice. Okay. So when did we do one no? So we play hedge, and then on our next no, which was resolved. Nice. So we got back. Okay. And then on our next no input, we got back waiting for input 5 credits. So here we should do make payment. We're not going to decline. We are going to spend Netrunner dot pooled credits for corp. Okay, and then that should be that paid. So let's just jam through a few more times and see what we get stuck on. It just did a bunch of resolving. Okay, make payment resolved. Credits in pool 10, and only 2 hedge funds in our hand when we had presumably 3 to begin with. I guess 1, 2, 3, 4, 5, 6, only 6 cards, whereas we had 7 before. Nice. I think that's fully worked. I guess the last thing we can do to verify is look in archives. Also, I'm kind of surprised we kept getting resolved and not a none there. Let me just jam a few more in. We probably 1 away from a none. Yeah, we were 1 away from a none. Okay, let's look in archives. So if we do, discarded objects. The implementation is going to work a lot like hand objects, but we care if it is in archives or the heap. So we're going to go grab every discarded object in our test. We'll say we'll do this. We'll say let discard is discarded objects for card. Here I'm going to say print line corp hand. Okay, and then we'll say credits in pool, and we'll say corp discard. Okay, everyone ready to run this test? And we will be done for the day. Discard contains hedge fund. Hand has what it has, 10 credits. That all worked flawlessly. And I am much, much happier with this implementation than I am with the last one. I feel like I can actually move and get things done. So, with that, I think we're done. Thank you for tuning in, everyone. It's been a much more technical stream today than last time, but I'm going to keep doing these. I'm going to finish with a little plug. I've lost my job, so if anyone has a lot of money and wants to hire me, or knows a company that might, please do. My Rust programming skills have been on full display today. I think the speed with which I whip around this code base probably speaks for itself. So hopefully I can end up not unemployed eventually. But we'll call it there. So thank you very much for watching, and I'll see everyone probably in a couple days' time when I do